Hello friend, here is the problem. A 2 to the power n is the sum of two odd consecutive integers, and B 3 to the power n is the sum of three consecutive integers for all natural values of n. So we need to prove these two. So what is the concept? Concept is very simple. Even number is always represented as 2 to the power 2 into k, and odd can be represented always is the form of 2k plus 1, where k belongs to integer in all the case, both the case. So and one more thing is operation of plus, minus and into on even odd. So this table you need to remember always. Here I am going to explain. Suppose you have even odd, odd, these three things, and you are doing plus or minus, and you are doing division, multiplication. So what is the result? So when you do plus or minus on even numbers, two numbers, one, so even plus minus even is always even plus minus odd is always odd, and odd plus minus odd is always even. You can check all this taking example some number. So when we do this operation, plus minus operation on even two even numbers, result is even. And when you do plus minus operation on one even another odd number, the result is odd. And when you do plus minus operation on two odd numbers, result is even. And what happens when we multiply? So if you multiply two even number, result will be even. If you multiply even into odd, will be even, and odd into odd will be always odd. So this table is pretty much good to solve many problems. So let me start solving this. So here first we need to prove 2 to the power n is always the sum of two odd consecutive numbers. So 2 to the power n can be written as 2 to the power n minus 1 plus 1, which is nothing but 2 power n minus 1 into 2, which is nothing but 2 power n minus 1 plus 2 power n minus 1. So because 2 times 2 raised to n minus 1 is nothing but 2 raised to n minus 1 plus 2 raised to n minus 1. Now you subtract 1 from here and add 1 here. So what we are doing, subtracting 1 from this term and adding this term, 1 changes nothing. So this is now, because 2 to the power any number is always even because it is even, and minus 1 it brings it to odd. Again this part is even and plus 1 is odd, so this is again odd. So we can see these two are consecutive numbers. Why consecutive? Because difference of these two is only 2. So this minus this, you can subtract this to this, you will get 2. So these two are odd numbers and consecutive numbers. Now we have to prove second, this proof of A, proof of B. So 3 to the power n is the sum of three consecutive numbers. So 3 power n can be written as 3 into 3 raised to n minus 1. Again same principle. Now 3 to the power n is 3 times, so we can write 3 times 3 raised to n plus 3 raised to n plus 3 raised to n minus 1. 3 times 3 raised to n minus 1. Now if we'll add, subtract 1 from here, add 1 here, there will be no change. So this number and this number, these are the three numbers which are consecutive, because this plus 1 is this plus 1 is this, and which is equal to 3 to the power n. So 3 to the power n is the sum of three consecutive numbers always. Similar, you can represent another form also. If it is 4 to the power n, 4 to the power n is 4 times 4 raised to n minus 1. 4 to the power n is 4 times 4 raised to n minus 1. 4 to the power n is 4 times 4 raised to n minus 1. 4 to the power n is 4 times 4 raised to n minus 1. 4 to the power n is 4 times 4 raised to n minus 1. 4 to the power n is 4 times 4 raised to n minus 1. 4 to the power n is 4 times 4 raised to n minus 1. 4 to the power n is 4 times 4 raised to n minus 1. 4 to the power n is 4 times 4 raised to n minus 1. 4 to the power n is 4 times 4 raised to n minus 1. 4 to the power n is 4 times 4 raised to n minus 1. 4 to the power n is 4 times 4 raised to n minus 1. 4 to the power n is 4 times 4 raised to n minus 1. 4 to the power n what will happen? You can analyze on the same principle. Thanks.